Hello, everyone, and welcome to another episode of DABCC Live. I'm excited about this episode. We have Splunk with us today, and particularly, if I can spit that word out, Jason Conger. Jason is one of the architects, evangelists, one of the gurus over at Splunk, and he's going to talk about, what all this means and how it fits into our world too, within the virtualization and cloud world and Citrix world and VM world. So, really focused. Presentation, webinar we have for you today. I hope you guys enjoy it. So with no further ado, let's just dive on into it. Jason, thanks so much for taking the time to be with us today.
Yeah, great. It's good to be here.
Yeah, I look forward to this. I really do. So as always, I like to ask the first question before we get into anything. Who are you? Can you tell us just a little bit about who you are?
Sure. So my name is Jason Conger, and I first, way back when I was first getting started in the industry, I started out the Novell track, and then Citrix came along and fell in love with Citrix technologies and started doing that pretty much exclusively for the remainder of my career. I've done hosting provider stuff and worked for Citrix down in Fort Lauderdale around the same time you were there, Doug. And today I'm working for Splunk, doing a lot of Splunking data in the desktop virtualization industry.
Well, that's excellent. Excellent. Splunking. I love Splunk. You guys have so many different forms of the word Splunk.
Yeah.
So with no further ado, let's jump into this, into your presentation and of course demo. So unfortunately, I guess I should probably say this. So for those listening or watching this, you might be expecting the webinar that we recorded about a week and a half ago. Unfortunately, thanks to an issue with GoToWebinar, we lost the video. So Jason, being the great guy that he is, took the time to re-record this with us so that we can share this with you, because it is just amazing content. So it's a little bit different than a typical or DABCC live webinar because of the fact that we don't have you guys. We don't have the audience asking questions. That's going to be my job. But yet Jason here, we don't need anything other than Jason. So right, Jason?
There you go. That's right.
Okay, so I got that out. I had to say it. Sometimes you have to air some dirty laundry, and that is we had a problem with the recording, and so we overcome our issues, and hopefully you guys enjoy the show. I know you will. So Jason, tell us about Splunk. Let's do this thing.
Yeah, so that's why we're here today, is to talk about Splunk and how it fits in this particular industry. So the thing that I want to talk about today is, first of all, answer your question right away. What is Splunk? So I'm going to talk about what is Splunk and how it does its magic and all that. Then we're going to talk a little bit later about what a Splunk app is. So really just two things we'll talk about today. So if we start thinking about what is Splunk, a lot of people ask what the name, what does that name mean, Splunk? And so the founders, when they were trying to think of some kind of cool name for this idea they had about exploring machine data, they said, well, Splunking is exploring underground caves, so we'll call this company Splunk, because we explore machine data, go get on that deep level of machine data. And so that's where the name Splunk comes from. And what you see there in the bottom right-hand corner of your screen, that's actually Splunk's mission statement. It says, to make machine data accessible, usable, and valuable to everyone. And so I like to take that mission statement and says, all right, well, how do we go about delivering on that mission statement, right? So the first thing when we talk about delivering on that mission statement is you got to understand what machine data is. So machine data is a time series unstructured data. So all these things out in some kind of enterprise are producing machine data. Log files are machine data. If you ever go open up a log file for an application, you'll see a bunch of timestamps and some stuff after it. That's machine data. Servers, like actual physical hardware, they're producing machine data on SNMP traps, for instance. Your other software like hypervisors, they're producing machine data. All your Citrix infrastructure for XenApp, XenDesktop, things like that, they're producing machine data. Your VMware environments, all these things are producing machine data, and they have some value in and of itself. But where the real value comes in is when you are able to search over that machine data from a very broad platform, and then make correlations from one piece of machine data to another piece of machine data and find really what's going on in your environment. So we need to make your machine data accessible first, because just going and looking at log files is not very accessible. But then to make it usable and valuable is when we start to make some of the statistics on top of the machine data and searching and exploring that machine data. So that's what Splunk's job is.
Perfect, Jason. I'm going to try to be the audience today, so I do have a question for you, and that is you guys support not just machines but also like hardware. You might not necessarily think of it as a machine, but routers, maybe phone systems, things of that nature too.
Yeah. So for instance, we have verticals in. I mean, really, what we're talking about today is IT operations, but there's verticals that people use Splunk because Splunk is a platform for machine data. You can use it for anything. So we're talking IT, but people are using this in like the oil and gas industry and measuring wells and drilling, and all those things are producing machine data. Elevators and buildings are producing machine data. People are using Splunk to gain analytics from that type of machine data, not just IT operations, but you mentioned specifically routers, switches, firewalls. All those things are producing machine data as well. All of it can be ingested by Splunk and give you that real-time analytics that you need in your enterprise environment.
Perfect. And then would machine data, does that also mean at the same time, or maybe a subset of that, application data?
Yeah, absolutely. So if you're getting into application performance monitoring, things like that, you can take in your application data because applications are producing data. So machine data, the if you think about application is not really a machine, but machine data just being a time series unstructured data stream. So applications produce that as well. So time series means here's a date and timestamp, and here's what happened. And applications do that when they're logging. So Splunk has no problem ingesting that type of data and making some valuation out of it as well.
Perfect. So back to you.
Yeah. All right. So carrying on. So the thing about machine data versus any other kind of data is not, there's no upfront structure. There's no schema to it. So when you think about like a database, so when people are designing applications and then a data type application, they'll go to open up a database designer and they'll start thinking about, all right, let me think about what kind of data this application is going to hold and make some tables and some fields that go in these tables and start making relationships between all these things in the database, and that's called a schema. The thing about machine data is unstructured. There is no upfront schema. There is no standard that all of these things that are producing data follow. So Splunk has no upfront schema. There's no kind of connector that you need to have if a server is producing data in order to massage that data to fit into some kind of schema on a database end. So there's none of that with Splunk. Splunk actually doesn't even know what the data looks like ahead of time. You can send any kind of data to Splunk. The only caveat is it has to be text readable. And I kind of put an asterisk on that sometimes because we do have some capability to decode some binary data. So for instance, in your NetScaler app flow data, that is actually delivered via that's binary data, and we can decode that data and get that into Splunk to get some analytics out of that as well. So as long as it ends up in some kind of text form before we ingest it in Splunk, that's not a problem. And then also what that gets us is, I'll talk about this on a slide later on, is scale. So when we get into the term, it's been thrown around big data. Big data means you need to scale very large and be able to ingest data at a very rapid pace on a very scalable infrastructure, and then also be able to run analytics on that and get your results back very, very quickly. So when you start to get into just hundreds of terabytes of data coming in every day, if you have a database in a schema that's conformed to all that, then the scalability becomes a big factor, and there's a lot of infrastructure components needed to handle that kind of scale. And all of that is built into Splunk right out of the box. And we'll talk about that a little bit later.
Cool.
All right. So that's just
we're ready for the demo already?
Yeah.
I love it.
I don't have a lot of, I'm a technical guy, so I do more demo than anything. So Slides only get you so far, but seeing it is believing. So
That's exactly right.
we're going to get into the demo about what Splunk is.
And before we do that, Jason, I always like to ask this question because I get so many people like yourself, companies come on and they say, okay, well, let's show this demo, and here it is up on the screen. But what did it take to get to this point? Meaning, here we, able to log into the Splunk console, but how do you install it? What does it take to get to this point?
Yep. So I'm running, this is actually a hosted demo that I'm showing right now. It's up on an Amazon Web Services just instance. I actually have this exact same demo running on my Mac laptop here, and then I have some Windows VMs that I run this on as well. But Splunk will install on almost anything as far as the actual binaries go. So it'll install on Windows, Linux, HPUX, all kinds of flavors of Linux as well. So installing Splunk is very, very easy. It's just kind of a wizard that you click next, 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 finish, and you have Splunk up and going as far as the platform for your data. Then once you have Splunk up and going, you have to get your data into your Splunk instance. So what you're looking at here is just a centralized Splunk instance, and I have some data coming in, and you can see that on the screen that shows my index data and the sources of the data, and farther on down here the source types and the host of where that data is coming from. So I have to get the data into Splunk. And there's a couple of ways of doing that. First of all, I can go to this Splunk instance and I can reach out and grab data from the local machine of where this particular Splunk instance is installed. You'll notice this is just a web interface. And so I can get this local machine data, or I can tell Splunk to reach out to other machines remotely and get some data from them. Now, if you're in a Windows environment, which most, our audience today will be mostly a Windows environment on their enterprise environment, you can do that remotely. There's some things that you start to go into with like Active Directory security and Kerberos authentication and things like that you have to make sure that's all set up on the Windows side. Conversely, you can install, you can think of it as an agent, as we call it a universal forwarder with Splunk terminology. And what that does is you install, it's just a Windows service on a machine, and you can say, go collect all this information on this machine and send it over to the Splunk infrastructure. And we can collect data that way as well. So most of our desktop virtualization environments, our customers, they're using the universal forwarder to collect the data and send it over to a set of Splunk servers that are load balancing it. So that's, that's a long way of answering the question of what you're seeing today. It was very easy to get set up because it's just installing on my laptop and have some log files that just ingested, versus installing universal forwarders on lots of machines. We have automated technology to do that and push out the configurations, automated technology to deploy all that. And that normally when I go into a proof of concept for a desktop virtualization situation, from the start of the week to the end of the week, we already have data and doing customizations and custom dashboards. It only takes like just a few hours to get the actual agents out there and pumping data into Splunk. It's not a very complicated setup at all.
Perfect. So if somebody wanted to, one of the things, as always, we say, hey, try this out, download the eval. If somebody wanted to download the eval and try it out and do what you're going to show us today, they could do that just on their laptops and have this thing up and running in just a few hours.
Oh, yeah. Yeah. So, everything I'm showing you today, you can actually go and download for free. So the way Splunk is licensed is we license on how much data comes into your Splunk infrastructure in a day. And we kind of have to do it that way because we don't know ahead of time what kind of data comes in. You can pipe in any kind of data that you want. And so the only way to really get a license out that's really generic enough is how much comes in a day. We don't care how long you store it, how much you store after it comes in. As long as you have disk space to store it, we don't care. We're not licensed on how much you store long term. Cool. It's just how much comes in every day.
Cool.
And then also, as the data comes in, we never roll up the data. We never aggregate the data. It stays granular for as long as you have disk space to store it. So if you have tons and tons of disk space to store this granular data forever, you can do that. And then there's some mechanisms built into Splunk where we can roll off to different classes of storage if you want. That's not a problem either. But that's an important thing to remember is we never change the data. We never roll up the data. So you have your granular detail the same granularity you have from the second that it comes in to 10 years from now. You have the same granularity going forward.
Cool.
Okay.
Okay. Well, let's see it.
All right. So this is what Splunk looks like when you first install it out of the box. And if you think about what Google does for web pages out there, so Google is a platform that goes and it indexes web pages or just web content, so PDFs, Word documents, web pages, all this kind of stuff. So when you as a user need to find something, you have a search bar and you go start typing that in. That's kind of the same concept with Splunk. So all this data, we have some data coming into Splunk, all this data is coming in, and the user interface out of the box is a search bar to where you start going and typing in things that you want to look for. Like I could just type error right here and it would show me, come back with all the stuff that had the word error. Or if I type a username in here, it would just come back with all the stuff and has that in there. Since I have a lot of different types of data in here, today I'm just going to focus on just a XenApp use case. So the first thing I'm going to do is a special command in Splunk called index equals, and then I type the name of the data. So what I'm doing right now is I'm narrowing down the scope of data to just look at XenApp data. So I have hypervisor data in here. I have storage data in here. I have all kinds of data in this instance, but I just want to look at the XenApp data. So what I just did is I told Splunk, give me just the XenApp data. And so what we're looking at here is all these things that we're seeing on the screen. Each one of these lines are an event. And so you could think of this as a line in a log file. So, looking at this, this still isn't very usable. I've made the data accessible because here it is, I can see it. But our mission statement was to make it accessible, usable, and valuable to everybody. So I'll start to talk about how this data starts to become valuable and usable. Because as of right now, in my opinion, it's still not very usable. We see some data here, but it's not a lot of value going to the organization. So what Splunk is doing here in real time is Splunk is looking at all these events that were returned, and it's saying here's some interesting fields over here. And what makes a field interesting is it sees the same field name in more than 50% of the data that's returned. So there's a bunch of fields. We can click on this and we can see all the fields that it found of all the data, but it's only going to show us over here on the left hand side things that are in 50% or more of the events that got returned. So some things that you'll start to see that look familiar is something called farm name. I can see some farm names. I'll see some machine names, things like that. So these are XenApp servers. So everything that is going on right here is what we call late binding. So Splunk doesn't know what this data looked like before it came in. It's figuring out as we go what's going on here. So if we're sitting here in a XenApp world, something somebody might want to know is how are our applications getting used? And so we might want to narrow down not just XenApp data, but applications, published applications. And so things that are on all pieces of data is we have these three things right here called a host, a source, and a source type. These pieces of metadata are tagged to every piece of every piece of data that comes into Splunk. And a host is just the thing that sent the data in. So these are your XenApp servers. The source is actually what generated that data. There's a lot of PowerShell scripts in here, log files, Windows event viewers, all that stuff will be the source. And the source type is tagged in the application itself. So when we start talking about applications in a few more minutes, you can kind of tell your applications when you collect this type of data, just tag it with this source type. So this is user-defined stuff here as far as the source type goes. And so, like I said, I just want to really focus in on application data. So I'm narrowing my scope to not just XenApp data, but XenApp application data. And like I said, everything's being done in real time with Splunk. So you'll see these interesting fields. We have a lot more because we narrowed our scope down. We have a lot more fields that appear in more than 50% of the data that is shown as we're looking at it right now. So that's what's going on here. And so you'll actually start to see some things that look more familiar to a XenApp administrator. People that have been doing this a while will know that app browser name is actually the publish application's advertised name in XenApp. So when you go publish an application and you give it an application name, that's called the browser name. We alias that later on in the XenApp app, so you can say application name instead of browser name, but by default, out of the box, Citrix calls it browser name. So here's all our published applications that are in this, this particular environment. So we're starting to get a little bit more usable in our data, but still, this is really just kind of like reading log files. So where we really start to get into the power of Splunk is when we start doing some statistics on all this data. So we have all this data, it's accessible, but we're not really doing much with it. All we've done is narrow our scope so far. So what we can start to do here is Splunk has its own search language. You can think of it similar as a command line language or PowerShell type thing, where you take one set of data and you pipe it along to a command, and you can pipe that along to another command and keep on going down the pipeline to massage the data as you go through. So I want to run some statistics on this application data, because maybe I want to provide a dashboard or a report or something like that to my manager on once a day, once a week, whatever, on what applications are getting used out there. So I'm just going to do some stats. So I'm going to say stats and count by browser name. So what I'm telling Splunk to do right now is give me the statistics on how many are the number of times you see each browser name. And so that's going to tell me the number of times each application was launched within the time window that I gave it. So like I said, machine data is all time-based. So we have, by default, we can choose different time ranges here. So I could go over the, right now I'm on the past 60 minutes. I can go the past 24 hours. Something that's real interesting, you can do real time. And so Splunk will show you the data as it's coming in as well. So 30-second window, 1 minute window, that will show you the data in real time as it comes in as well. And then custom times, if you want to go into a particular date and time, you can do all that. But I'll just go back for the past 24 hours for this particular demo. And you'll see all the counts change for the particular application. So it's showing me how many times each application has been launched within that time range. So we can kind of get some statistics going on that way. By default, everything is sortable on here. So we're sorting things by the count, browser name, whatever. All of this is built in for you. So that's kind of cool. That gives me some statistics on what's getting used, some real quick and dirty things. But a lot of people really like pretty pictures and charts.
I love pretty pictures and charts.
Oh yeah, and it makes, it's impressive. It looks good and it makes you look good. So it's a win-win for everybody. So what I'm going to do here, instead of doing a stats, I'm going to tell Splunk to do a chart. So I'm going to say, Splunk, go take out this data and do a chart.
And everything you're doing, Jason, from charts to stat, this is all built in Splunk syntax, correct? These aren't applications on top of it yet. This is the default syntax, correct?
Yep.
And
this is what we call core Splunk.
Okay.
Yep. So this is anybody that went and downloaded Splunk. You can do all these commands, no problem. And this is all documented on Splunk's website. There's I forget how many commands. Well over several hundred commands. We find that probably only about, for the most part, especially in this type of industry, probably only if you learn about 10 or 20. 20 is a lot. I normally only use probably about 15 to 20 commands when I'm doing apps, and then I have to go look up others. But you kind of get a feel for what's going on and what the different commands do. And there's inline help as you're typing as well. You'll notice when I start typing again in a minute that kind of the help drops down to help you get along while you're typing on the search bar here also.
Perfect.
That's pretty cool. But I just changed this from stats to chart, and the data looks the same because it still is just showing the number, the every application name and how many times it's been launched. But when we use that chart command, we can go over here and click this little chart button, and that will give us a nice chart.
Cool.
And so here's our pie chart, and it gives you the mouse over. It'll give you some pop-ups on each one of those, and you can enable drill down if you want to get down on each little pie slice. Or you have different kind of charts as well. You don't have to use a pie. You have all these different types of charts, and these are all built-in charts that are with Splunk. You can extend Splunk if you have some other type of chart that you want to use with Splunk. You can do that, but Splunk gives you these right out of the box. So what I've done here is I've created this pretty chart, but what would be really nice is if I could give this, I don't want somebody to have to go type this search and go click the chart button and all that. So what Splunk allows you to do with this data is create dashboards. And so what I want to do now is that I'm going to create a dashboard out of this particular visualization of the data. So I'm going to go say I want to create a dashboard panel. So you have dashboards, and dashboards have multiple panels. So first of all, I have to create this panel, and I'll call it apps. Top apps, that sounds good. Top apps, I've tried that before, I guess. Then I'll click next, and what Splunk's going to do next, it created the panel for me, and it's going to say, do you want to create a new dashboard or use an existing dashboard? Well, I don't have an existing dashboard right now, so I'll just call this the DABCC dashboard, and then click next. And then they're going to say, here's the title for the panel, the visualization. Yeah, I chose Pi before, so it just defaults to Pi. I could change it here to something else if I wanted to. And then I click Finish. And then what happened is Splunk created this pretty dashboard for me that has a unique URL that I'm able to give somebody. So just go to this URL, and it will give you all this visualization going on here. So here's our pretty pie chart. And all the stuff that we did with the searching going on in the background is going on back here to generate this chart. And it will update every time somebody comes to this dashboard.
Cool.
And so now I've gotten some value out of my data. All right. Something else that you might want to do, just to show you kind of another take on the same concept, is say that you wanted to, in addition to the apps being used on this dashboard, maybe I wanted to show the user activity, so user logons that are going on per server. So I want to add that type of information to the same dashboard. So again, I can narrow my scope down to XenApp data. And this time we were looking at applications before, the type of data we were looking at. Say maybe now we want to look at the a session. So just tell it to look at just sessions. And again, I'm just going to use the same type of Splunk commands. I'll do a stats. Actually, this time I'll do a dedupe, because I want to get the unique users per server. So as you know, if I don't want to, if I log on to the same server more than once in a day, that's still just me on that day. So maybe I just want to get the unique users per server. So there's a dedupe command built into Splunk that says I want to dedupe some data. And you can dedupe on multiple things. So I want to dedupe on the username and the server name. So that's just going to get me the unique users for every server. So I'll throw out the duplicates if that's duplicated. Okay, and then I could do that stats command again if I wanted to. Say make stats count by server name, and this will give me a table of here's every server and the unique users, the unique user count per server. So that's cool, but again, we want to do this charting stuff. But what's cool, besides just a regular chart that just gives you a kind of a static graph, you can do this thing called a time chart as well. And this will give you a chart for every time slice along the way, because machine data is time series data. I want to give a unique time slice for every piece along the way. And what that's going to do is, like, here's a time stamp, and then to the right is how many users were on every server along that time. But again, since we're using that chart thing, we can come over here and I can do a nice chart. So this will give us, like, here, if I want to go show everything, and this is over the past hour, really what people are more normally interested in, maybe the past day. So you can kind of see what's going on in the past day. And you'll see nobody's coming in at 4 a.m. and then all of a sudden we have some users coming in through the system, and that's kind of what you would expect. And again, everything, the mouse overs will show you on each thing going on here. This is all just built right out of the box of Splunk. And so it's like, that's a good chart that I want to save on that same dashboard as well. So I'll create a dashboard panel out of this one as well.
Yeah, that's an interesting chart. Basically, your people in your company do not work from 8 till noon. They drink a lot of coffee, but at 4 p.m., right before they get ready to leave, they're extremely productive.
Yeah, well, also keeping in mind that Splunk is a West Coast-based company as well.
Oh, that's the excuse. Okay.
Yeah. So anyway, here we go. So now, instead of creating a new dashboard name here, I'll just add it to an existing dashboard, that one we created earlier. So we'll click our dashboard that we created earlier, click next, and this is all steal the line chart that we chose earlier. So we'll say finish, and let's go check out what our dashboard looks like now. And so now what we have is our dashboard that shows our apps and our logons going on. And so we can give somebody this URL to go and see this information in real time. We can also say, I want to schedule a PDF delivery here, or generate a PDF, print this, whatever we want to do. We can do that as well. And also, if we don't like this layout, say we want to go turn on edit, and I want to move this over here next to that, we can do that.
Oh, neat.
And then maybe I don't like the pie chart anymore. Maybe I want a column chart. So edit the visualization over here. Instead of pie, I want a column chart. We can do that, save it off, and they'll change it from pie to column for me. And there we go with that. Of course, that we don't. Our app names kind of disappeared a little bit while we did that because I don't have a whole lot of screen real estate going on. But here we are. We can see all that, and this can be done per user as well. So, as like somebody could give me a default dashboard, and I could say I don't like the layout of that dashboard, and I can go change it just for me, and everybody else sees the old dashboard. That's not a problem.
Very cool.
So now, if we go back and start to think about that mission statement again, we made our machine data accessible by being able to search it, and now it's a little bit more usable and valuable by being able to do these these visualizations on top of the data. Where it really gets valuable, as we'll see in a minute, is where we start correlating different types of data.
That's really neat. Jason, one of the questions we had from the actual webinar that we did not successfully record was how does this fit on top of existing, let's say, monitoring solutions? And I remember a particular question about EdgeSight, and so is this a complement to that? Is it a replacement for it? How do you guys see that?
Yeah, so a lot of people in especially larger enterprises, they have some siloed monitoring solutions already. So in a Citrix environment, a lot of people will have EdgeSight, especially in a Zen app. Haven't seen a lot of adoption in the Zen desktop with EdgeSight, but they'll have some siloed monitoring solutions. And so Splunk does have an API to where you can play with other systems. So for instance, we'll look at an alerting mechanism in just a minute where we can say, I want to go integrate with somebody's ticketing system. Or if you have an existing monitoring system, we can take data out of a monitoring system and use that to complement what's in Splunk. Or we can take what's in Splunk and use that to complement another monitoring system. So for instance, with EdgeSight, could you, depending on what you're doing with EdgeSight, you could do there is some overlap, obviously, what we're looking at with EdgeSight and what Splunk can do. You could take some of the EdgeSight data and use that to complement Splunk as well. Or you could, there are people that will go and say, Splunk is good enough, and they can do their basic needs that EdgeSight would have done before. So some people have replaced, are thinking about replacing EdgeSight normally from a Zen desktop environment because there's a big disk impact with EdgeSight.
Yeah.
So and then I guess I didn't mention that with Splunk, when we're collecting data, we actually never. I have to say this with an asterisk as well. We never write the data to disk. It goes over the network directly to your Splunk instance. It's not written to a temporary, like a temporary database like EdgeSight does, a Firebird database. So what happens whenever Splunk collects the data, it goes across the network directly to the Splunk instance, and it doesn't write it to disk. The reason I put on an asterisk on that is if it can't contact the Splunk central instance, it will write it to disk until it can make that established connection to the Splunk instance again, and then it will upload its data to Splunk. But it doesn't need. That's a very rare occasion versus something that's built in as the infrastructure for Splunk.
Makes sense.
Okay.
Thank you.
All right. So the last thing that I wanted to do, as far as everything I'm doing right now is just core Splunk. We haven't even talked about what an application is yet. But the last thing I wanted to do is just kind of show you how you would set up an alerting system. So we're doing a lot of kind of visualizations and looking at what's going on in our environment, and we can set up alerts as well, so we can look for particular events that are going on and say, let me know if this happens, because everything in Splunk is just a search. So search for your application usage, search for your user logons, but maybe we have a cap on how many users we can support on a given server, and we want to know if we go over that limit. So that's really easy to set up in Splunk as well. As with anything with Splunk, it starts as a search. So we're kind of getting old hat at this now. So we go index equals, if I can type, index.
And I love it as you're typing, it's showing that, the syntax examples.
Oh, yeah.
And
that's
really verbose. That's pretty cool.
Yep, that is. And that's actually, built right into the product. And you can create your own commands and your own syntax and all that also. So that's kind of cool and very extensible.
Very cool.
So, at this particular alert, what we're going to do is we're going to see if there's too many sessions on a particular server. So again, everything starts out with a search in Splunk. So again, I wanted to do unique users, so I'll do that dedupe thing again. Username and server name. So I'm telling Splunk, give me all the session data, but only the unique users per server. And I'll use the stats thing again. I want to do the count by server name. This is the same exact search that we started to do earlier, but now we can do another command here, and we need to say where the count is greater than 300. Sure, that sounds good. And so what's going to come back now is, I guess I don't have any counts greater than 300. I guess I'll have to go 50. Where the count's greater than 50. There we go. Okay, so I didn't have any greater than 300. So I have some greater than 50. So say, if you're sizing your environment, which you could use Splunk to help you size your environment to figure out, the max number of users per server, and we want to know if we go above that at any time. So we can say, all right, here's our search that lets me know if I go above that threshold. And so just like we were creating dashboard panels earlier, we can come over here and I say, I want to create an alert instead of a dashboard panel. And so it creates this little wizard, and I'll say too many users. And we have these options on when to trigger this alert. So Splunk can look for this in real time. Whenever it sees this, it'll let you know. Or if I had some other kind of alert that I just wanted to run on a scheduled basis, either every hour, every day, something like that, I can do that. Or monitoring real-time window. So if it spikes within this real-time window, let me know. Otherwise, don't worry about it. So we have some options there on when to send this alert. But I'll just say whenever it happens, let me know. And then we have these actions that you can take on the alert. So, the very basic one, send me an email on this alert. So it says, all right, here's where to send it, the subject of that, and then if I want to include the result of the particular search, I can include it as an attachment as a CSV. I include it inline in the email or as a PDF. And also something you can do is you can run a script. So maybe I want to you could take some corrective action if you wanted to, or I could generate a ticket in a help desk system, something like that. Basically, any kind of script that the operating system understands, Splunk can execute. So if you're using a Linux system, this might be a Python script. If you're running Splunk on Windows, it might be a PowerShell script, something like that. And then you have some throttling on if you want to suppress alerts after a certain amount of time. I'm not going to click next on this one because I don't have an email system set up. Since this is a hosted demo, there's no email system set up for this to actually go through and deliver the alert. But that's how you would do that, and that would allow you to get email alerts or take corrective action or open tickets or do other things with the alert if you wanted to. Cool. Pretty much the same thing doing visualizations, the same thing as I'm doing alerts here. So that's all built right in the box as well. Okay. All right. So
now we got apps.
Yep. Yay. So we'll go back over to PowerPoint land over here. And so that was a demo. That demo was just Splunk. If you just downloaded Splunk right out of the box, that was just Splunk. That's what you get. So as I mentioned earlier, I wanted to talk a little bit about the architecture of Splunk. So what you just saw, what I was doing is this architecture that you're looking here, actually only half this architecture. So I was that user up there, and I was using Splunk to go through and do my searching and my visualizations and all that. Those bottom three boxes that you see there, those are called forwarders. if you wanted to install forwarders on remote systems to send data to Splunk, you can do that, which that's a lot of times what people do, especially in a Windows environment. But like I said, you can configure Splunk to reach out and grab data from remote systems. You just have to get into some authentication mechanisms going on, but it is possible. So that's the very, very basic thing at Splunk. But like I said, Splunk has scalability built right into the product. So you start in some larger environments, you start to get into an architecture that looks more like this. And so you have your Splunk guys at the top now. You have multiple people doing their Splunk stuff, and they want to go do their searching. And you need to scale out to multiple Splunk servers because the amount of data coming in is too great for a single server. Or if you're doing very complex searches, it's going to take a while for a single server to reply to that. So you scale out, and there's automatic load balancing built into Splunk. So you don't need some kind of special hardware load balancer. You don't need some kind of clustering technology. You don't need anything like that. You just install another Splunk server, and you point one to the other, says there's your other Splunk server. It just has to be network addressable, and they take care of the load balancing and fault tolerance out of the box. So you have one, you can have 100, whatever you want. It's just built in. It's in there. And then you can send data from multiple sources to what we call this just a Splunk cluster. And in order to be able to do that, you think about when I'm running my searches, you can think of it almost like a RAID array of disk. So you start distributing these searches to multiple Splunk instances at the same time. And that's done through something called MapReduce. And MapReduce was actually a technology or a framework that was invented by Google. And this is what Google does to rapidly return you however many billions of results that if I go type DABCC and it returns 300 million results to me, it did that using something called MapReduce, where it goes and finds that term in its indexes around the world, and it offloads that to all these other nodes around the world to bring back the results. The way I think of this is it's kind of like a multi-threaded process. So where a process will send work off to multiple threads, and when that thread is done, it reports back into the process, and you have a multi-threaded process application going on. So kind of the same thing with how Google does its indexing, which is exactly how Splunk does its indexes, which allows Splunk to scale very, very, very large.
Nice.
And finally, if you get into a very, very big architecture that is a worldwide architecture, you can have multiple geos that have a Splunk architecture, and then you can search worldwide over all of those. Again, as long as it's network addressable, then you can hit those over the network. Then you can use the MapReduce to go and grab the data and give you very, very fast results to all that data that you're looking for. And also there's role-based authentication built right into Splunk as well, so you can control who sees what as far as your data goes. And so that's all right there in the box.
Very cool.
All right, and so here's the second thing we're going to talk about today, and this is a Splunk app. And so basically, a Splunk app is just everything that we did here already is just somebody, whether it was Splunk or there's lots of people that are out there developing Splunk apps. They package up a bunch of searches and dashboards for you to where you can just go plug that into your Splunk system and go. And so we'll show right now the Splunk app for XenApp. So this is what the Splunk app for XenApp looks like. And basically it's just, it's the same types of visualizations that we were doing before with Core Splunk. And we just did a bunch of those for you out of the box that were kind of relevant to a Citrix environment. So we ended on doing alerts. We don't have those enabled for email by default out of the box because we don't know who they need to go to. But for XenApp, we'll run the same searches for alerts and show them to you on a nice pretty chart here. But you can go into the box out of here and say, in addition to showing them on a dashboard, I want to also deliver them to email. So you can do that as well, straight out of the box. Also, I mentioned earlier that where the real power of Splunk comes in is when we start tying data together. So this is a very common use case that you'll see, especially in a XenApp environment, is a user calls in and says it's slow. And you know that one?
Well, I wrote down a question. I was going to ask you, okay, Jason. So you're the admin and I'm the CEO, and I call you up and say, last night I couldn't log in, and you say, well, why? Well, it just kept dropping me and was slow. So
Yeah.
what do you do?
Yep. So it's slow. That's like I used to run a service provider, and that was like the big thing is slow. And then they learned the term latency that says latency is too much latency, and it's like what's causing that, because in a XenApp environment there's a lot of stuff involved in a stack to deliver that application or desktop to the end user. So there's networking. If you're virtualizing your XenApp instance, there's the hypervisor layer. There's a physical hardware that it's running on. There's the network stack. There's if you're using shared storage, all this kind of stuff plays into a user's experience. And so with Splunk, all of that stuff is producing machine data, and we're able to show you all the pieces that apply to the user's experience. So just for demonstration's sake here, we're going to say this user called Dan called in and says it's slow. And I mean, again, since this is all time series data, it could have been slow over the weekend. We can go back and see what it was over the weekend. So Dan calls in and says it's slow. And so what we're going to do is say, all right, Dan, I'll type in your username, and I'm going to see which server you're on during that time. And so because this is generated data, I know the bad server going home. So I'm kind of cheating a little bit, but you pick the server that he was on during that time range, which you can find out through the session statistics, and say, all right, let's see what was going on in your session at that time. So what we're doing here is we're transferring over here to see the results of what was going on during Dan's session on that server during that time range. And so we see a bunch of numbers and a bunch of icons here. And so basically all this is we're going and picking apart the different pieces that applied to the stack for Dan's session, and we're scoring them. And these are all just numbers that you can modify yourself for your own environment, but we just had to put some of the industry best practices out of the box in here. And so if you fall within a certain range, we'll just say it's info, or if you fall within a different range, we'll say it's alerted, and a different range is critical. So you can do all these range. It's actually a command in the Splunk Search language called range map. So based on the range map, we'll show a different icon. So what we're looking at here first is we're looking at the network stuff from Dan to the server, and so his ICA session. So we're looking at Dan's ICA session. We say, yeah, you got plenty of bandwidth, but your session latency is pretty high. So we click the little drop down thing here, and we can see how long is it, what's over the time frame that we have chosen, what does it look like over time.
Cool.
And so we see pretty much sustained high latency for Dan, which actually is not that big of a deal for XenApp, because ICA can adapt to that. If it was very jittery, then we know we have some kind of network, and we can do a network trace or something like that. If we have the network data in Splunk from his home or wherever he is to the server, we could get that data as well, but we don't think that's a problem. And so what we see next is on the next layer of his stack, we see the XenApp server that he's on. And so we can see the percent processor time is pretty high. We can drop down our little thing here again to see over time how long has it been high. And we see, all right, well, his percent processor time has been pretty high over the past 24 hours. We're really having a pegged CPU on here. So let's look farther down the stack to see what might be causing it. It could be a runaway process or something like that. All right. So, but what we do see here is Splunk looked for this server name up here to see if it had that in the virtualization index to see if it was running on a hypervisor. And it turns out it was. It's running on this hypervisor called XSHost-01. And also the hypervisor is pegged at 100% right now. Let's see how long it's been that way. So we drop down our list here. And we can see it's over the past 24 hours, this hypervisor has also been very, very high. So it sounds like we have a hypervisor issue. So if we click this guy right here, that will take us into a different Splunk app called Splunk for Server Virtualization that will show us particular information about that hypervisor that this particular XenApp server was running on. And so we see this big red X over here that says the average vCPU/pCPU is 50.17, and you're like, well, what does that mean? So we just mouse over here and it'll tell you what that metric means. So what that's telling you is for every one physical CPU, you have 50.17 virtual CPUs assigned. So this particular hypervisor host is oversubscribed, and there's too many VMs or VMs with a high number of CPUs running on this hypervisor. So we need to either do some live migrations or shut some VMs down or something like that. But that's what's causing Dan's poor performance in this particular case. So in this case, it didn't have anything to do with Citrix. It was the hypervisor host that was running on.
That was so cool. So I mean, just drill down the stack, boom, boom, boom. There you got it.
So same thing. We have Bob calling in this time. Same complaint. Things are slow. What's slow? Let's go figure out what's going on in the stack for Bob. So this time, Bob was on this server. Before, Dan was on a server called -000. Bob is on this server called 001. So we look at the same things. Let's look at the stack. We'll see the ICA session latency. We can check that out. Same kind of deal. We don't think that's a problem. The XenApp host looks pretty good on its thing, except for the disk transfers look a little bit high. Let's see what's going on with the disk transfers. We have pretty high sustained disk transfer. We really want to see that down around the 50 millisecond range. We're really high. So something's going on with the disk here on the XenApp server. Well, this particular XenApp server uses a shared volume that rests on NetApp storage. So what we're looking at here is, well, first of all, you'll notice that there is no hypervisor layer here because this is a physical server now. So we're only going to show you the parts of the stack that apply. So hypervisor doesn't apply to Bob on this server, so we're not going to show it to you. But since it is using a shared volume on NetApp storage, we'll show you that. As a storage person, normally a good rule of thumb of write latency sustained above 10 milliseconds is kind of bad. It's actually pretty bad and will impact performance. So we see our write latency is over the past 24 hours averaged almost 60 milliseconds, and it stayed pretty high here. So now, same problem Bob has, things are slow, as Dan had, but now we see it has nothing to do with hypervisor because A, hypervisor doesn't apply, but we can see, again, it's a disk transfer problem on the XenApp server, but it's caused by high write latency on the NetApp filer because we have NetApp data coming into this Splunk instance as well. We're able to make that correlation. And so there we go. We know what the problem is, and we can go either if there is a NetApp app that is available from Splunk. It's in beta right now. We could drill down into the NetApp app to do the same thing we did with the hypervisor, or we could just go do our own investigation, call the NetApp storage administrator, maybe a storage, one of the controllers is not load balancing correctly or something like that. So we have a problem there. So same problem, different manifestation this time. Okay?
That is neat.
And so this is all, like I said, this is a hosted demo, and this is generated data to where I could tell a story. So what I wanted to do over here is I want to switch over to Splunk's actual instance of XenApp. And so this is Splunk's internal XenApp farm right here. And so I just went ahead and preloaded the data, and here's me running on an actual server. Everything looks good here because this is real production hardware, but I just wanted to show you kind of like a more complete stack. So here's me. Here's my ICA session going on. Here's my XenApp server going on. Right here, it is running on a hypervisor. This one's on Zen server. It could be Hyper-V, it could be VMware, it could be anything. It doesn't matter. But here's the hypervisor. This particular hypervisor is running on hardware. We're using Cisco UCS hardware to run these hypervisors, so we can show you some information from the hardware. So here's the hardware. Again, we are using NetApp. Here's real NetApp. We can see some spikes here, but overall we're consistently write latency under 10 milliseconds, so not a problem. I have a NetScaler front-ending the SSL VPN connection coming in, so we'll show you some stuff about NetScaler, and of course Windows Event Viewer and the running processes and all that is from the Windows OS. So this is a more complete stack to show you everything that's going on. All of this data is very different. It looks very different, but we're able to make those correlations and pick out those things because Splunk can make all those correlations for us to make it very easy to see the different pieces of the stack as it comes down. And then, of course, you can add other stuff because if you say, all right, well, here's the stuff, this is the XenApp app that you can go download from Splunk right now. this is what we give you out of the box. But out of the box is very extensible, and the app itself is open source and free. So you can go see how it was done. And it's all just the core Splunk stuff that I was doing earlier, but we just did a lot of it for you.
Jason, I was going to ask you that if we can extend this app, but it's very, I mean, it's just, wow. That's powerful, man. I mean, that's the type of information we want to get to, and we use tools like like an Edge site or something to do with a heck of a lot more headache than what you just put me through.
Yeah. So just to give you an idea, this is an actual when I created a form and all the visualization, it creates XML in the background, and it's actually pretty easy to read. So here's a row, and here's a table in that row, and here's another row and a table, and here's a chart. So all those things I was doing earlier, here's the search that's behind that table, is very easy. So if you go download the XenApp app, you can go open up the XML files, and this is what you'll see, stuff like this. So you can go modify it. You go see how that search was done. Change it to your environment if you want. And if you want to go create, if you want to write scripts or just point to a log file or whatever, this is a script that goes and grabs some Citrix XenApp data. Anything, you can write any kind of script that the operating system understands. So this is a PowerShell script that goes and grabs some XenApp data. Anything that ends up on this, that would have ended up on the screen, is what ends up in the index for XenApp. So it's very easy to, if I want to collect some more information, if it's already a log file, you just say, tell Splunk to look at that log file. If you need to write a script to go grab some data against an API, like the Citrix stuff here, you can write your script, test it, run it, and it's spitting out the stuff that you want, and then you just tell Splunk to run that script. And whenever Splunk runs it, whatever would have ended up on the screen is what ends up in the index. So it's very easy to get Splunk data into the index. Make sense?
Yeah, completely.
Okay.
Well, Jason, we're right at the top of the hour, okay. So we want to keep this thing about an hour. But is there anything else? That's impressive, and you guys have just thousands of applications. So if somebody wants to go out, well, you're going to talk about it right now.
Yeah. So that
I should pay attention. You have everything organized, don't you? You don't need me.
Well, heck yeah, I need you, man.
Oh
yeah. So just wrapping up, if you want to go, the apps are free. Go download them for this thing called Splunk Base. You can just type Splunk Base into Google and you'll find it, or splunkbase.com. It'll take you there, whatever. That's where you go download the apps. There's tons and tons of apps out there for different use cases. We just talked about one today. We have this forums where people is very active, and then we have you can go and look for local Splunk events. Also, we have these things called Splunk Live, where Splunk employees will be there doing a show. It's kind of like a users group, except it's always the content is driven by a Splunk customer. So you just don't hear Splunk talking about how great we are. We'll have Splunk people that are using Splunk day in and day out come and talk about how they use it. And then we do have an annual conference that people can attend if they want to. It's in Vegas every year, and I go to that conference. I'll be there. A lot of the Splunk people will be there as well. And download it for free. I mentioned earlier you can download Splunk for free. Just go to splunk.com. You'll see the big free download button in the top right, and you can install Splunk, start running those search commands, and start Splunking your data. And I think we did questions along the way, but if there's any more, we'll go ahead and answer them.
Yeah, that's all I have for you, Jason. Unfortunately, we lost a lot of the questions when we lost the recording. So what I want to do is I want to throw it out to you guys. If you've enjoyed this episode, or if you have any questions, please email us or send them over to us at Twitter. I'm Douglas A. Brown, at Douglas A. Brown. And Jason, what's your Twitter account?
At Jason Conger.
At Jason Conger. So Jason doesn't know that he's going to be bombarded with questions via Twitter, but if you guys have questions, use Twitter, or just email us directly, dbrown@DABCC or jason at splunk.com. And that's correct, jason at splunk.com, correct?
I don't know if that one works. I know J Conger, Jason.Conger. I know both of those work.
Okay. So email us and we'll answer your questions. But you know what? To be honest with you, I think you did such a great job that we don't have any questions. What we want to do is we want to play with it. And so we can download this thing for 100% free and just have at it. And it just doesn't run on Windows. It runs on what? Windows, Mac, Linux, like Solaris even, and AIX. You have an AIX version?
Yeah, you got it, man.
That's sweet. So yeah, so you guys can just have fun with this thing is the best thing to say is play around with it, enjoy it, and then if you have questions, let us know. There's Jason and a bunch of other wonderful guys over at Splunk who will get you guys answers. And what else do I say, Jason? Thanks so much for taking the time. This is really informative. I really loved it. Every time I see Splunk, I'm sort of blown away. Really, really, and I want to ask you the competition question, but you really don't have any. You guys do something completely different than everyone else.
I mean, the use cases are endless.
Yeah, yeah, it's truly because it's almost like development in a way. You know what I mean? Where in development you can build anything, but it's almost like you can build any type of you have your raw data and you can do anything with it.
Yeah, it's kind of development, but not really.
Yeah.
So anyway, yeah, I guess you can look at it that way.
Yeah, but at the same time, you're not scared of it the way you are development, right? There's a lot of people that are like, oh, I don't know how to develop, but you
Oh
don't
yeah,
have to. You don't have to. I mean, you don't even have to use search. You can just use the applications.
yeah, absolutely.
So yeah, I really love what you guys do. I really do. So Jason, we're right at the top of the hour. We're right at 1 hour exactly. So I will go ahead and say thank you very much for taking the time to do this twice for us. Once with our audience and once just the recording. But I really, really enjoyed watching it and learning twice. And I learned so much both times. This is great. Thanks again, Jason.
All right, thank you.